Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0532 indicates a problem specifically related to the air conditioning pressure sensor circuit in the Honda Fit models from 2015 to 2020. This code reveals that the pressure sensor is sending a low voltage signal, which could lead to inadequate cooling performance, affecting passenger comfort. The AC pressure sensor is a crucial component located in the AC system, helping the vehicle monitor the refrigerant pressure and ensuring the system operates efficiently. The malfunction can create a chain reaction of issues, including potential damage to the AC compressor or reduced efficiency of the air conditioning system, making it vital to address the issue promptly. Ensuring the proper function of the AC system not only affects comfort, but also drives fuel efficiency in your vehicle. But DTC P0532 specifically denotes that a low voltage signal has been detected from the AC pressure sensor circuit. The AC pressure sensor plays a vital role in monitoring the pressure of the refrigerant in the air conditioning system, which in turn affects the operation of the compressor. This sensor is typically located on the AC line and is connected to the engine control module, ECM, known as the powertrain control module, PCM. A consistent low voltage reading below the threshold of 0.24 volts requires thorough investigation, as it signals that the sensor may not be functioning correctly. Without accurate pressure readings, the AC system's control logic could mismanage the compressor operation, leading to reduced cooling efficiency. Identifying the root cause of this issue is essential for restoring optimal AC functionality and ensuring comfort in the vehicle. Identifying the causes of DTC P0532 is crucial for effective troubleshooting. One common cause is a faulty AC pressure sensor, which may not provide accurate voltage readings to the PCM. This could occur due to age, physical damage, or internal sensor failure. Another potential cause is an open circuit in the wiring leading to the sensor. This could be due to corrosion or physical damage in the wiring harness. Additionally, there can be a short in the PD sensor line, resulting in unintended voltage changes that mislead the system. Understanding these causes helps focus the diagnostic efforts and ensures that proper measures are taken to rectify the underlying issues. Drivers may experience several symptoms when DTC P0532 is triggered. One primary indication is that the air conditioning system becomes inoperative, leading to driver discomfort, especially in warmer weather. Additionally, even if the AC appears to be functioning, the cooling performance may be noticeably poor, providing inadequate relief from the heat. Another common symptom is the illumination of the check engine light on the dashboard, which serves as a warning to the driver that the vehicle has detected a malfunction. Recognizing these signs early can help in addressing the DTC and restoring the AC functionality effectively before further complications arise. The first step in troubleshooting DTC P0532 involves problem verification. Begin by starting the engine and allowing it to idle, which sets the vehicle systems to their operational state. Next, turn the blower switch on to ensure that air is circulating through the climate control system. Subsequently, switch the AC on to engage the air conditioning system properly. With these actions completed, you will then check specific parameters using the Honda Diagnostic System, commonly referred to as HDS. It is crucial to monitor the AC pressure sensor's output. If the sensor is providing a voltage reading lower than the established threshold of 0.24 volts, the issue is confirmed, necessitating progression to the next troubleshooting step. Moving to the second step in this diagnostic process, you must first turn the vehicle to the off or lock mode. This precaution ensures safety and prevents any accidental electrical issues while working on the vehicle. After securing the vehicle, disconnect the AC pressure sensor 3P connector. This is a crucial step to isolate the sensor from the circuit. Once completed, turn the vehicle back to the on mode, which will allow the systems to be powered up. Once again, check the AC pressure sensor voltage using the HDS. If it remains below the threshold of 0.24 volts, your next step will involve examining the sensor itself or the wiring associated with it to determine the root of the low voltage reading. In the third troubleshooting step, measuring voltage becomes paramount. Ensure that the vehicle is in the on mode while the AC pressure sensor 3P connector remains disconnected. You will need to check the voltage across two designated test points, specifically between test points 1 and 2. Test point 1 corresponds to the AC pressure sensor connector number 1, and test point 2 corresponds to connector number 3. The expected reading here should be approximately 5 volts. If you achieve this reading, it indicates that voltage is properly supplied to the sensor, and that the sensor itself should be replaced, as it is likely faulty if the low voltage issue persists. Conversely, if you do not reach the expected voltage, further investigation into the wiring or connectors is warranted. As you approach step 4, it's essential to verify the integrity of wiring related to the vehicle's AC system. Begin by placing the vehicle into the off or lock mode. After this, perform a shorting connector switch operation with the HDS. By doing this, you can ensure that no erroneous signals are sent to the PCM. Disconnect the PCM connector A, referred to as the 51P connector, and prepare to check for continuity between the defined test points. Specifically, you will be verifying continuity between test point 1 at the AC pressure sensor connector number 3 and test point 2 at PCB connector A number 40. If continuity is present, it signifies that the VCC5 wire is functioning correctly. At this juncture, consider updating the PCM software if it's outdated, or substituting the PCM with a known good unit to see if the DTC clears. In the final troubleshooting step, you will be evaluating for potential short circuits in the PD sensor line. Like previous steps, initiate by turning the vehicle to the off or lock mode. Perform the shorting connector switch operation with the HDS again to avoid mismatched electrical signals. Disconnect the PCM connector A, 51P, just as before. Now you need to check the continuity involving test point 1 at the AC pressure sensor connector number 2 and also test point 2 to body ground. If continuity indicates that there is a short in the wiring, then repair the PD sensor wire leading from the PCM. However, if no continuity is evident, it suggests that the wiring is intact. In this case, proceed to possibly update the PCM software or replace it to verify if the DTC P0532 resolves. After completing all necessary repairs associated with DTC P0532, it's critical to perform a final verification of the repair. Begin by clearing any stored DTCs from the vehicle's system to ensure that you start fresh without any lingering codes. Next, run a functional test of the AC system to confirm that it operates as intended without any issues. During this test, monitor and verify that the voltage levels at the AC pressure sensor return to normal thresholds, indicating that it is communicating properly with the PCM. Completing this verification process not only confirms your repair was successful, but also enhances the long-term reliability of the system in providing effective cooling to prevent future occurrences of DTC P0532. Implementing a routine maintenance schedule is paramount. Regular checks of the wiring connections, related to the AC pressure sensor can help spot any early signs of wear, damage, or corrosion that could lead to sensor failure. Keeping connectors clean and securely fastened minimizes the risk of poor connections, which are a primary cause of low voltage signals. Additionally, staying on top of PCM software updates is beneficial, as manufacturers will often issue updates to improve performance and address known issues. Engaging in these preventive actions not only prolongs the life of the AC system, but also enhances the overall driving experience by ensuring adequate climate control. In conclusion, effectively addressing DTC P0532 involves a systematic approach to troubleshooting and repair. Identifying and replacing faulty components, such as the AC pressure sensor, is crucial for restoring functionality to the air conditioning system. Following the structured troubleshooting steps allows for a thorough examination of the electrical connections and circuitry associated with the AC system. Lastly, implementing preventive checks can mitigate the risk of running into similar issues in the future. By prioritizing both immediate repairs and long-term maintenance, vehicle owners can ensure their Honda Fit remains comfortable and reliable for an extended period. Please like and subscribe to the channel. See you next time.